Hi, my name is Charlie. From a very early age, I've loved to take things apart and see how they work. When I was about 8 years old, I started to get interested in how computers work and programming. My parents showed me an introduction to JavaScript with Khan Academy. But after I completed that, I had technical questions for my parents. They then introduced me to Phil, a family friend, who had a career in programming. He introduced me to a Java program where it would simulate me running around the house and picking apples from a tree in the backyard each time. After that, Phil and I moved on to the Lego NXT robot and Robot C with a maze-solving project.
I'm Charlie's friend Phil. Charlie, I brought you the nutrition you asked for. In the next part of the video, what you'll see is alternating sections. There are parts of the video that take the form of an interview where we talk more about the concepts behind the maze-solving robot. And then there are other sections where we concentrate on the code that we collaborated on. I'm here today with Charlie Martin, robot designer and programmer, to talk about his project of making his NXT robot go through a maze. Shortly we'll show a video of the robot on its path to success. But first, we'd like to review some of the background to this project. Charlie, we programmed the robot to go through two different types of mazes. One was relatively simple, and one was more complicated. Can you explain the difference between those two types of mazes?
In the first maze, there were no dead ends. In the second maze, there are dead ends.
The robot can solve the simple maze by looking for openings in the walls and following them. The more complicated maze requires some decision-making. For that, the robot needs something that the simpler maze does not require. Can you recall what that is? I'll give you a hint. The Scarecrow from The Wizard of Oz.
It needs a brain!
And now, can you remember exactly what the robot needs to do with his brain? There are two things.
It needs to know where it wants to go next, and it also needs to remember where it's been so that it doesn't go in the same place twice.
In order to make a decision about where the robot should go next, the brain needs three pieces of information. Can you remember what those are? And let me give you another hint. These are the same pieces of information that you and I need to get through our everyday life.
It needs to know where it's going. It needs to know where it is and where it's been.
As programmers, we need a way to keep these three pieces of information together. How do we do that in the C language?
We would use a struct. We also need to give the robot's brain a sense of direction. We choose points of a compass: north, south, east, west. In Robot C, we use an enum. I learned about Excel spreadsheets in my computer class at school, and we decided that a maze is like a spreadsheet. It has rows, columns, and cells. Anywhere in the maze, the answer to the question, "Where am I?" is a row and column in the spreadsheet. We put these two pieces of information together in another struct called location. For the entire spreadsheet in Robot C, we need a two-dimensional array of rows and columns.
By the way, can you tell me which cell the robot starts in?
2, 2.
And how does the brain know that the maze has been solved?
When the robot reaches cell 0, 0.
In the video, you'll see the robot enter a cell and stop and turn its sensor to the left and right. Can you tell me what the robot's doing at that moment?
It's looking to see if there's an opening on any side of it.
So that it can then
move into the next cell. The robot's brain thinks about moving north, south, east, and west, but it gives commands to the robot to point straight ahead or turn left, right, or 180 degrees before moving forward.
how do we code the translation between the brain's idea of direction and the commands the brain should give to the robot?
We wrote a function in Robot C. The parameter P current heading is the brain's current compass heading. The parameter P direction is the desired direction, and the return value is the type of turn the robot should make.
Dude, 9 years old, and you're already a typical programmer. A comment, code goes here, but no actual code. I'm speechless. Okay, well, time to get to work. Without this function, the program will surely crash and burn. Charlie, wake up. You've been coding all night again? All I needed you to do was that one function that we talked about. That, I just can't keep you away from this stuff. Well, finish it up and then we'll go on to the next part of the video. Looks like you're getting somewhere. I see you've got a switch within a switch. Can you restate the logic in words if I tell you that the current heading is north and the desired direction is south?
If the current heading is north and the desired direction is south, then the function returns the enum value turn 180.
Now we're about to run our demo of the 3x3 maze. I should say first that even though the 3x3 maze looks simple, it does have a dead end that requires backtracking. The program itself is general purpose and can handle mazes with many more dimensions.